Good morning, good afternoon. How's everyone doing? Good to see you here. Jessica, Kirsten, Knox, and Shivam. Put questions if you got them in the chat. It's time to get going. I got like DuckTales in my head. Bonjour. Noah, bonjour. Parlez-vous français? Is that how you say, do you speak French? Rajiv, good to see you here. Michelle, good to see you here. Solamente hablo español. No conozco... I don't know how to say I don't know other languages. I know un piquico petit un petit español. How should we write the report for the assignment? Is this 474, Shivam? 474, right? Oui. French is a pretty cool language. Are you talking about 474? 474, right? Is it 474? Let's talk about writing what is 474 deliverables. Great question, Shivam. Worth 100 points right here. We don't have a Friday theme. We only got like Wacky Wednesdays. So Wacky Wednesdays it is. Here we go. BS. Let's do it. Deliverables for assignment 3. Here we go. Awesome. Good to see you here, Cooper. Throwing out some points. So the deliverables for assignment 3 are twofold. One, you need to turn in kind of an instruction for your company on how to use the app, or not really an app. I said that to someone on Discord. I think I said app, and I think I changed it to like the functions. So, when we give people things that are coded, we have to make sure they understand how to utilize them. That's the business part of the analytics that we do. So you're going to be, let me see what I have open, coding. I think I closed out all the coding. We closed out all the coding, so we can open it back up. So you're going to be over here coding a function. You're going to do something like fun. Now you should code it outside the function first. I've been helping a lot of people, and I think one of the biggest things is sometimes we got to take it all out of the function. So we got here x and y, and now we have x and y are not found, so we have to think about how this works. We go x store into 2. Y store into 6. That's what we got right there. And then we go down here to our function. We say x and y is equal to this, but it's not going to work when I run name. This is, oh, it does? Oh, yeah, because I've specified them in the global environment. Now, it doesn't work because we need inputs to the function. So we go right here and we say x comma y. And now it still doesn't work because no one input anything. So we could do things where the function has defaults and we add the default values. So that was kind of we'll just call this add to things. This was a little bit of a speed run of creating a function. How are my 474 students doing right here with these concepts? Like this does 3 or 4 concepts within the idea of making a function, how a function has inputs, which are arguments. Arguments can have defaults. Oftentimes, to end a function, we do a return. This will end the function world and return that value. We create a name for a function when we make the user-defined function in the global environment. And then, the output of the function is going to be what it creates. And some functions don't require any inputs. We, of course, can call the arguments and put them in different orders when we specify them by names. Of course, it just kind of does that. We did minus. So you need to turn in, we don't have mice, there we go. You need to turn in this, like your RMD file right here. So I will be seeing your code. I will be seeing what you did, what you created, and I will be running it to see if it works. That's very important. Now, this is not the function you're creating. You're creating the function that does the calculation of interest with money in a bank over a period of time, and also somebody wondering how long they'd have to make payments for. What I think is interesting. So the theory behind, and 474, 475, or 201, ask some questions. Let me know. We only have one question right now, so drop some questions in the chat, whatever you want to know. Sam, great to see you here. Christy, Gustavo, Olivia, and Cooper, good to see you here. Drop some questions in the chat if you got them. We'll throw out some more points for you right there. Steve, good to see you. So maybe my brain works in reverse of most people. If I am buying a house, which eventually I will, and they say, oh, we can give you a 30-year mortgage. My brain doesn't think, pay that mortgage off in 30 years. What do you think Brian's brain thinks? Good to see you, Christy. What do you think Brian's brain thinks? Can you jump into Brian's brain when Brian hears we're giving you a 30-year mortgage, pay it off in 30 years? Brian's brain doesn't think pay it off in 30 years. What does Brian's brain think? There should be on Canvas as well. Tell me if you can't find it. I'll show it next coming up here. There should be a spot. You won't do it for each chapter. You'll just take kind of a general picture of your note cards. So as long as it's like, don't just take one and be like, here's my note card. As long as you do just a general picture of your note cards, and I can kind of tell that you've done it. It's a little bit of the honor system, a little bit. So I'll trust that you are submitting. So you'll just resubmit before each test. And if you just want to lay them out, it'll be clear to them that you've done the work. I might have to like say to someone like, excuse me, you only showed one note card, or you might have to like take a screenshot of your, if you did it on, what is it called? Quizlet. So what my brain thinks about when I hear you're getting a 30-year mortgage, my brain thinks, how quickly can I pay that off? How quickly can I go to zero debt? Maybe I just have a weird brain. That's a given. But so the idea of this is, what kind of payments, and this is the second function you're making, what kind of payments could you make on your debt to eliminate it as quickly as possible? And it doesn't have to be just for a mortgage. It could be for any debt at any interest rate over, with any amount of payments. So it's kind of a good thing to see right there. You could use it on student loans. It's just a debt payment planner to like pay it off as quickly as possible and see like, okay, if I'm making this payment right here, how long would it take for me to pay it down? I think we kind of think of these things in reverse to think, I have this debt for 30 years instead of I can pay off this debt, and if I paid at this rate, how quickly could I pay it off? So that's kind of my thoughts on your second function right there. Maybe someone will use it or consider those options in the future, and maybe we'll do a little more than business analytics. We'll do some sort of finance advice for people, which is kind of neat to think that maybe this class would save someone $20,000 in interest on their house. That's and then we can call and help them with their car insurance, extended car warranty. That's the thing. So once you make these functions, you need to. This goes to Shivam's question. Once you make these functions, you need to give documentation on these functions. So the function needs documentation outlining what the user is going to input. I preferably would want these to be one page. If there's 2, 3, 4, 5, don't make it 10 pages. Don't put code on this. This needs to be documentation like, let's go right here and go, the subtract two things function. Don't everyone, like, I don't know. This is kind of my, like, I always worry about typing these things. Someone's going to write like the exact same things I type. Like, use your own imagination. You're presenting this to the company. We here at Math Corp. I don't know how to spell Corp. Math Corp. Have created a new function that helps our users subtract two values. The function can be called by, what do we call it? Gotta go grab that. By typing, good to see you here, Natalie, because of interest. A lot of interest is going to cause a lot of money. By calling eyes to things and inputting two values. Below, we detail and you can show example values. That's acceptable. Like at the end of this, we might do that. Below, we detail the inputs to the function. You might go into yours, probably go into more detail. My function is pretty simple right here. And there we go. Cool. So x, a integer, or we don't want to say integer numeric to our customers, a number that will be input first. Y. A number put second. When the user inputs both of these values, they will see the output displaying for them, showing them the value of x minus y. It's important to note the following errors may be encountered. Yours would go into details like this. This is not something from mine right here. Something like that should be good. So we put our graph. You could put the you could say like an example, and here you want to tell them you're going to get a graph, right? So Shivam, that's right there. You want to tell them you're going to get a graph. You want to show how the function is going to work. Like like you want to explain to the user what they're going to be seeing, what's going to be happening. With as simple as a function I wrote right here, there's not that much to it. So there's really not that much for me to say. Some people did some really nice, like, I've already seen some that want to, a lot. What's really great about teaching is I get to see a lot of really good work. Like that I'm like, I really like how that person did it. Some people were using like some light blues and stuff, and it was like very nice. So shout outs to the people who've already turned some stuff in. So I've really seen some great work already. I'm like, yeah, that's a really nice way of doing it. Good to see you, Nolan and Sydney. Drop those questions, Sierra. Good to see you. So you want this to be documentation right here, walking through. If we were to make a plot or something, we'd probably want to show the plot of it. Make a plot right here and say like gain equals need better plot. There we go. I wish I was doing graphics all last night in a good way. Like I'm very happy. We were it's data that I can't last night I was working on a research project with somebody, and we were making graphics in R, and they look spectacular. It'll probably be published, so I guess I can show it then and be like, we made those in R. But I'm just like, the code is a lot of lines. It's like for one graphic, the code I think is about 70 or 80 lines of code. So, I mean, it's got everything altered. Like it's literally the axes and everything are defined the exact way we want them. Everything, the way the lines are, the way the points are, everything is very user defined to be exactly the way we want it. So I'm really proud of it. So a lot of, I don't know, making graphics is an art. So you might see this from some of my comments in your papers. This is, I mean, as long as you have your titles, I'd retitle those labels right there. I want to see a certain level of graphics, and watch out. Some people have definitely done things like this right here. Watch out with your graphics like this. Does everyone know? I know this is maybe something a ton of people know. Whenever you're reshaping an image, always do what? Who knows the answer to this? 100 points. And if someone has some more questions, thank you so much, Shivam. Good question. You're on like what the report will be. But whenever you're reshaping a graphic, always do what? Maybe there's instances where you won't, but pretty much in most cases, when you're reshaping a graphic, I think everyone knows this. They'll be like, come on, Brian. We know that. Whenever you're reshaping a graphic, like making it bigger or smaller, always do what? Maybe one person will be like, oh. Whenever you're reshaping a graphic, always grab on the corners. So the reason you grab from the corner right there, Sam, you got it. The reason you do that is it keeps the aspect ratio the same. If you don't drag on the corner, it'll actually change the aspect ratio, and you'll get some kind of Laffy Taffy. Hold Shift. Ooh. Okay, wait. What happens if you holding? What does holding Shift do? Does that, Michelle? Thank you for that comment. Does that help? I don't know that trick. There's so many tricks. There's so many like shortcuts, or so many like if you do this, it'll do this. Like there's so many like advanced things. So Michelle, if you want to, I don't see much difference happening if I hold Shift. I'm trying holding different buttons here. But no, so yeah. Let me know if that can like help out with doing something we want with graphics. Also, the way you drop. Can you do a review bit of B1 0 and B1? Like, yeah, let's do that. Let's talk about the slope and the intercept. Thank you, Isabel. Slope and intercept review coming up next. Also, the way you input a graphic, probably my top favorite one is this, but I always do it after I do my report. So when you're inputting a graphic, if you click the following, it will put it over top everything you've done. So you have to watch out because you can place it over, but I kind of like the freedom to move my graphic where I want. And so a lot of times I might say we need the graphic over here. Keep the same proportion. Yeah, it might be on a Mac or something. Michelle, keep those answers coming in. That's the goal, kind of, to keep the graphic proportionately the same. So if you're doing that, it might be on, it wasn't doing it on Word as far as I could see. But yeah, you want to make sure your graphics are nice and presented well, which actually goes to tool one also. Sometimes people will lose some points because their graphics will have parts of the screen they shouldn't. So whenever you take a screenshot, make sure, like if I'm taking a screenshot over here, I don't want to include, imagine you're putting this in a PowerPoint or something, and think about what you wouldn't want. So if we're over here in PowerPoint, that's kind of what I've always said to students when we talk about like taking good screenshots. It's like you're going to be at the big company event. It's company X, and you're at their event, and you drop in right here, and you say, "Here's my image." And if we take a look, it's got some extra stuff. The suggested designs are so nice. I mean, this might not be bad if we just crop this. If we just go here and go to crop, and that's what we can do to make it nice and neat. It's not the worst thing ever. It's not that bad. We got it rather quick, so there we goes that. And there you go. Not horrible. That's stat tool 1. Not horrible. That's oh, it's not cropped anymore. Now it is horrible. Okay, let's talk about some B0, B1, talking about slope and intercept with regression. Great work, everybody. Keep those questions coming in. A little music here in the background. Deliverables. Deliverables. Sure, that's how we spell it. 1815, stat tool 1, test 1 review. Slope and intercept. Let's go do it. Okay. Can we call the code whatever we want? For example, vector. Yeah, I mean, just kind of make sure it makes sense to a certain extent. Scale it. Maybe. Oh, yeah, the graphic. So let's talk about that slope and that intercept. Here we go. Tell me in words what the intercept means. Just tell me in words. Tell me in words what the intercept means. Tell me in words. The intercept is equal to leaving blanks. It's like you're hearing a message and I'm like, the intercept is equal to. Exactly. Great job right there. I actually muted myself on that. Great job, Jessica. More points in the chat. It's where the line crosses the y-axis. It's when x is equal to 0, right? And that's a really good way to remember it because the intercept is known as what in notation? So if we remember, it's when x is equal to 0, and we can see it here visually. It's the highlighted portion right there. It's what in notation. Like, it's a good way to remember it because it's when x is equal to 0, and the intercept, don't do algebra. The intercept is B0. Jessica, great job right there. More points in the chat. That's B0. Now, the slope is for each one increase in x. What is the slope? It's for each one in x. What is the slope? What is the slope? Fill in the blanks. I don't know. Do you guys like that where with the mute? I think it's, I don't know. I haven't done that much. I'm trying to it's a new idea I just had. Sometimes ideas pop into my head and I do them. And then students say they like them or not. And I say, okay, that goes out of my teaching regimen. What is this slope right there? It's for each in x. What is it? How would we describe it in words? We use words to describe things. We could use interpreted advanced to describe it too. For each 1 unit increase. So now think about that. 1 unit increase. So the slope is known as what? The slope is known as what? The slope is known as what? If it's for each 1 unit increase in notation, B's are what we call coefficients. So it's B1. Great job, Jessica, right there. It's B1. So when we write a regression equation, we ask, why is something happening? That y variable is the variable of interest. That's what we care about. And then we say maybe an x variable explains it. Here, the variable of interest. Maybe there's something that explains why something is happening. Why is this happening? Great job, Chris. You're right there. Thrives over run. More points in the chat. So now we need to write a line. And a line, as you probably have heard, maybe in an algebra class, has y equals mx plus b. Now, if you look at where the x is, it's with the slope coefficient. We write ours a bit differently. We call it b0 plus b1x. Now, if you think about the way this is formatted up here, add down here. Good. Don't worry. Sorry, algebra. Sorry, algebra. Little poking fun at algebra. We still have our y up here in classic algebra sense. We have our slope here. Slope is over here. And now we have our y-intercept right here. Y-intercept there. And then the x variable that is the explanatory. Does this help everybody better understand? I hope the color coding here. What are people's thoughts? Are like just understanding this. This is how we write it in statistics. That's how it's written in algebra. Y equals mx plus b. But if you're wanting to memorize the statistical way of doing it, which you're not required to, I mean, I guess to a certain extent, because we do call it B0. Awesome, Jessica. Glad this helps. Remember, B0 is when X is equal to 0. B1 is for each 1 unit increase in X. And then you can see how it's associated with what you've learned in algebra, most likely previously. It's all right. I took that out of my head a few years ago. Now, what's really cool, and I'll mention this here just briefly, is what we could have is if you do take 320 with me, shout out to if you're in business analytics, is check this out. What if we used multiple X variables? So does anyone know if I have what's called here B2, like the second coefficient would probably be with the what? Now, we haven't done this. What do you think if we had another X variable? What do you think that X variable would be called? And this is what's neat about writing it this way. What do you think we'd call the second X what? B2, the second coefficient, would be with the what X? What would it be with? B2 would be with what? Now, this is multiple regression, which we're not doing into a 1, but it also shows how we do this notation. B2 would be with what X? If we had another X, we'd call it what? Like another explanatory variable. Like we say, this car's price is explained by how old it is and the condition it's in. So if we said the car's price is explained by how old it is and the condition, so price would be over here. And then we'd have some intercept. And then we'd have how old it is. So this would be like age right here. And then it would have a coefficient. Oh, it should be negative. If it's age, it's going to be negative. Well, that's the worst negative I've ever seen. X2, great job and good movie, X2. Nice. Is that a classic movie now? It's like 20 years old. Buying some cheap cars. They're like and then the condition right here, like it's a positive condition score, would be some, so it'd be X2 right here. And then it would be like a positive 120 and then condition right here. So that is just the coefficient of the second X. If you notice right here, B0 has 0 X's. We are not doing multiple regression though, but I hope that makes sense why this notation can kind of help, because if we add in more X's, we just call it B1, X1, B2, X2, B3, X3, and it just follows that each one. Can you do a quick review of interpreting a residual plot? Cool, yeah. Let's do that. I'll put that right here. Perfect time to ask, Natalie, and there's never a not perfect time to ask, but we just kind of talked about slope and intercept right here, finishing up this topic. So we have open topics, and let's do reading a residual plot. Stat 1, test 1 review. Reading a residual plot. Let's talk theory of a residual plot here for a second. And we're making Natalie a mod right here. Awesome job, Natalie. And some points for you in the chat. Okay. So when we think about a residual plot, what is a residual? What is a residual? A residual is what? What is a residual? And there's so many cool things we can do. What is a residual? What is a residual? Actual minus predicted. Noah with that 474 knowledge right there. Great job. Noah, 500 points. Remembering that 201 knowledge. Noah, shouts to everyone right there. Oh, great job, Jessica, earning those points along. Actual minus predicted. Exactly. And so, I didn't see, don't worry, I didn't even see the typo until you cracked up. Jessica, 500 points for you too. We're just being super happy this morning. Great job, Jessica, and great job, Noah, on remembering, especially in the upper level classes, because this plays a huge component. Shout out, yeah, Janae, great job, Janae, right there. Helping with that knowledge. Awesome. We got so many great professors in our department. So with this right here, let's take a look at how we calculate a residual. Okay, so that's the what model right here. We just talked about this. That's the what model. What model is that? What model is that? That's the what model. It's a regression model. It's a linear model, right? Linear regression, all that good stuff. So this is a linear model to explain these data points. Now, we're going to do a little bit of a weird pattern right here. This definitely has an issue with what? Ooh, I'll throw another 500 points if anyone knows the big word I like. I'm going to throw 100 points for the regular word and 500 points for my favorite word. Because I get to say it if you say it in the chat. What's going on with this plot? It's very what? Plot thickening, that's worth 100 points. Heteroskedastic. Nolan jumping in there with some heteroskedastic. What does hetero mean? Hetero means, great job, Noah, also. Oh, Noah and Nolan jumping in right there. Butchered the spelling. It's actually with a C or a K. It's like Rock knows.
It doesn't matter.
It's either which. It's weird. It's a word that's spelled with either or. So hetero meaning different. And so differing spread is what heteroskedastic is. Now, that's just a fun word. We're probably never going to say that to anyone we talk to about this other than another statistician. Someone says heteroskedastic, and you're like, oh, you know some stats. And they're like, yeah. It's a secret, like, it's like the secret stats handshake that we just say heteroskedastic. And then someone's like, I know that word. So beyond knowing a cool word, let's look at the importance of what it means. So this is the plot we have. And then to make a residual plot, you take that plot and make it what? To make a residual plot, you take that same exact plot and you make that same exact plot what? How does that become a residual plot? Make it flat. There we go right there. Great job, Jessica. Take that plot, make it flat, and then that's now a residual plot. Now, it's not as pretty as you're going to see because what actually happens is we redo the axes. So... Really? There we go. Look at that. Magic. Get some, yeah, why not Space Pen? You're here. So now we redraw the axes and we set this equal to 0. Because things would have a 0 residual if they're where? Things with a 0 residual would be where? Things that have a 0 residual would be where? Why would that have a 0 residual? Explain to me conceptually why on the green thing right there would it have a 0 residual? Because the line is the prediction. Keep going. I'm kind of helping out with this. Because the line is the prediction and the dots are the actual. The lines are the predictions and the dots are the actual. And if something's on the line, what would happen here? Just think about this conceptually. If the dot is on the line, if the dot is on the line, then the what is the what. If the dot is on the line, then the what and the what are the same. That stands for residual equals actual minus predicted. If the dot is on the line and this is the residual up here, the actual match the predicted, so there is no difference, right? So what would you say about the model predicting that? Just think about what it means to have a 0 residual. If the residual is 0, then how'd the model do at the prediction? If the residual is 0, good. It predicted well. It predicted perfectly, Jessica. Great job right there. It predicted perfectly. There was no miss to it. It's perfectly predicted. But let's look at a positive residual. So now we're changing this. Whoops. There we go. Okay. Now let's look at Dwight. It's like quote 242, same right there. Dwight. Actual is you. Now this is, let's say, cheeseburgers you eat, or chicken burgers, whatever you prefer. Steak burgers, I don't know, whatever you prefer. Soy, what else they got? Gluten-free burgers. Gluten's in wheat. So you don't eat the bun, you just eat the burger. So I like to do this where there's like number of burgers. I think there we go. Number of burgers. And you ate 5 burgers before the test. 5. You scored a 100 on the test. But what? Explain to me that. You scored a 100 on the test. And actually, that needs to be moved up. There, better. You scored a 100 on the test, but what? Correct. Christy's on the right track. Your actual score was higher than you were predicted to be. Great job, Christy, right there. Excellent knowledge. So with this right here, calculate for me the residual, and then tell me what this means. You ate 5 burgers. It's just the X variable of interest. Apparently, burgers explains how well you're going to do at the test. Maybe it's like the month before the test, because you're not just scarfing burgers before the test. It's like a lead up to the test. This is in the lead up to the first test of stats when you had 5 burgers. I don't know how burgers explains things, but apparently, according to data, it does. This data, at least. If you can't tell, I sometimes craft the lecture around what I want. Might make burgers tonight. So what does this mean, and what is this value? How would we interpret this value? And then we could run some actual regressions and see some and look at those values. But what does this mean? Great job, Jessica, saying 30, 100 minus 70. Jessica's plugging in the values right here. Jessica found that the actual, I'm going to underline it while I talk about it, the actual value right here, which is this, is 100. Someone actually made a 100. Like, that is your score. KP, so good to see you here. They actually made a 100. They were predicted to make a 70. That means that the actual minus predicted, which is 100 minus 70, is going to be this distance right here. That is the same as right here. And remember, we just made that plot by making it flat. So this means the person scored, and I think Jessica put it so perfectly. We're just going crazy on the points here this morning. Jessica, another 500 points, because that's a 500-point answer. I think, let me read Jessica's answer aloud again. Jessica wrote, so you were supposed to score a 70, kind of predicted to. We estimated, or we would think that this person would score a 70. That's a good way of phrasing it right there, like predicted to score a 70. If you had that many burgers, which is your X variable, your explanatory, you did score 100, which is 30 above what you were predicted to score. So when you think about a residual tells you somebody's distance from their what value. A residual tells you somebody's difference. Are we doing? I'll probably do a little today. Good question there, KP. I think we will. We'll probably do that maybe towards the end. I did it. I did what I said. I included that question from yesterday. Wink, wink. I mean, it's in class. It tells someone their distance from the predicted. So on the test tonight, or on the coding test, would you like a positive or negative residual? Would you like a positive or negative residual on the coding test tonight? And tell me some more questions. We're going to do more questions here. On the test, maybe you say I want a 0 residual. I want to do what I'm supposed to do or predicted to do. There is no supposed to in statistics. There's only what might happen. I'm gonna grab this right here and show you something pretty interesting. Watch this. I would definitely want a positive. Going over loops and functions help. Yeah, we could do KP. We could do some loops and functions now, and watch this. Take a look at this. I don't have FPP3 loaded up. If you are in U.S. retail not found, oh, he creates so many data sets. If you're in the upper level classes, I'll just change it. OS arrivals. If you're in the upper level classes, we need to do a filter on this. Oh, it's so cool though. What? I've never seen it. Wow. It's a little bit, you know what we can do? 500 points. How can I get this so I can only see like one of these series? I've never done a decomp of multiple series like this. I want to make this graphic interactive, 500 points. And then I'm going to show you how this bridges back to 201 and your knowledge of 201. But I want to make this graphic interactive so I can remove out some stuff. GG Plotly, KP knows right there. Just throw it at GG Plotly. Okay, so let's take the full graphic, and we're just going to store it as graphic X. Store it as graphic X. Library, great job, Noah. They're also Noah and KP, excellent work. Plotly, now GG Plotly. And X. Okay, now let's take a look. And here it is right here. Oof, it's taken up. One problem I might have is those labels are really a lot. I'm just having a hard time today. What is the remainder over here? For those in time series, what is the remainder? And do you see how we have this big dip right there? That big dip shows up down here. What is, I guess I can be on the screen, what is the remainder of the series? It's the unexplained portion that's not explained by the trend, not explained by the season. So when you break something down into its decomp, you get the trend, which is like the flowy pattern through it. It's the trend cycle. You get the seasonal, which is like quarterly patterns. So we've got a quarterly pattern, which is kind of a wave going through it. Then we've got a trend cycle, which is kind of the linear / bend to it. And then we have the unexplained, which we are not explaining. If we were to put these together, this would be how much it misses by. So this remainder is also kind of a what? That remainder down there, 201, 475, 474. That remainder is basically your what of these two. It's what's left over. It's the residual. That's the residual. It's what's left over. It's kind of what we would have if we use this to predict those values up there. You can actually put these two components back together. It's a residual. Yes, Jessica, great job. That's a residual. Because what's happening right here, for those who don't know, we have an original series up top. So this is your data right here. Then we're taking the data and breaking it into two components. It's like if you had a cake and I said, take the flour out of the cake, take the sugar out of the cake, and take maybe like the vanilla out of the cake, and then we would have components of the cake. So we have the trend cycle, which is a component of that. Good to see her, Met. Then we have the season, which is like the quarterly pattern. So that's like an up, down, up, down, up, down, up, down, 4-quarter pattern right here. And then this is what is not explained. And if you notice how that big aberration up there, right down there, that big dip, it shows up here because it's not explained by the trend cycle and not explained by the seasonal. That's really a thing that was far off from what we would expect. Does it make sense to say this time period right here, we would not have expected this to go as low? It doesn't, it's a little hard to tell if let me zoom in a little less. That dip right there was a lot lower, and you can see it down here, was a lot lower than we expected. Like it usually dips there. There's usually a dip, but this one went more than we expected. So that is further away than what we would expected with the way it cycles and the way it's seasoned, the seasonal pattern of it. That dip right there was more of an aberration, and it's a little clearer to see if you do that. Like, I don't know why it looks bigger. I guess the scale. And what's so great about graphing this way is we can just change the axes or whatever. I guess we could zoom in on it more to make it look bigger. Ah! Yeah, so you can just change your axes. You can do whatever you want with these graphics. It's so nice. Anyways, but that's showing a little bit of the upper level classes right here where we do data analytics and we can break things down pretty quickly and look at it. I think there was another question, right? Oh, we want to do some coding, right? KP wants some coding. Let's go do it. What should we do? Should we do a function, a for loop, a function in a for loop? What do people want? Sam, so good to see you. I just want to say that. Sam, is when people have an icon, especially, I see the icon, and then it's so easy to remember like an icon. So Sam with that icon right there, Chrissy too, and Sydney. But I see Sam's icon. I like it. Always good to see people here. And you don't have to make an icon, but just when people have icons, I guess I don't have an icon. You're welcome. Oh, hey, Sam's in the chat. For loop and both together. We'll make a for loop, then we'll put it in a function. Okay, we're getting things ready to go here. We're gonna make a for loop and put it in a function. Okay, let's go check it out. For loop in a function. Coding practice. Okay. How do we write a for loop? 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 When we take the exam, do we submit on the portfolio? Yes, you do. I'll probably talk about that today in class. That way everyone hears it. Like, I like doing it in office hours too, but in class, it ensures everybody hears it. So how do we write a for loop? Counterintuitive, every time you write a for loop, do what? Counterintuitive. Watch out. A lot of times people don't do this. I'm guilty of it. You say, hey, Brian, you're not doing what you said. Every time you write a for loop, do what? Write that skeleton, which means we don't write the for loop. We go find Skeletor over there. He's excited that you got the answer right. Cheering you on right there. He's a good guy for once. He just plays a bad guy on TV. So with this right here, we're going to write a skeleton right here. One of my favorite things, and I haven't done it this semester yet, is, and it's so funny, I've been using this example since Tolliver was born. I'd be like, one day when he's learning mathematics, and I'll be like, hey, Darren, I want to teach your son how to count. You're like, he knows how to count, Brian. Well, I want to teach him multiplication. Brian, he knows multiplication. Okay, so we got to teach Tolliver a new concept today. Okay, Tolliver, we're going to teach you about exponentials and what exponential growth looks like. Does that make sense? So Tolliver, I mean, that's more of like a middle school. I got to watch out. One day I'm going to be teaching him calculus here. Show him these videos when he's older. So he'll be like, you've been talking about me for years on the internet. Like, my uncle is so cringy. So we're going to teach him. Let's teach exponentials to someone. Okay. Does that make sense? Now, what do you know if you take something like 2 to 0? Just know this, like, 2 to the 0 is what? 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 Or anything to the 0. It's 1. Great job, Noah, right there. 2 to the 0 is 1. It's kind of a weird thing how something to a 0. Wow, great job, everybody in the chat. 2 to the 0. I'm just so glad when people are listening and answering. That makes my day. 500 points. It's 500 points Fridays. No, we'll call it that. Maybe I should do 50 more Fridays. Let's teach someone exponentials. So we go right here, and we go 2 raised to the 0. Boop. Now, we do 2 raised to the 1. Boop. Sound effect. With this right here, what does it look like I've got? What does it look like I have? Now, there's ways to do this without a for loop, and the exam tonight says you can do things without a for loop, but I'm going to do this with a for loop. What does it look like I have? And we'll explain what that is. He is so happy when you do it. When you make that code, it makes his day. We got that skeleton. Now, if you're wondering, if you're watching this and you're like, what the heck's going on? A skeleton is something that is inside the for loop. It's like your skeleton. It's inside you. So we need to find the inside of this for loop. The thing that never changes, the skeleton of it never changes. Now, you notice that does change. Well, let's take a version of this skeleton and turn it into a true skeleton. So if you think about a for loop, you type FOR. Now, we're going to use the snippet because it makes life easy. You could type all this out, but why type it when we've got snippets? So we're going to drop inside of here our skeleton, but it's not a skeleton yet. Now, I know this says variable. I kind of variable holder. I almost put the portmanteaued the words together. The variable is the what holder for the thing that changes when the for loop runs. The variable is the what holder. So what is the variable? Because we're going to turn this into a skeleton by putting a variable, which is a what holder. It's a placeholder. Kirsten, great job right there. It's a placeholder. Now, you can confirm that you have it right by doing the following. You can actually do it outside the for loop to begin with by going here and storing it as something like, we'll call it P for power. I'm not going to call it I. You can call it P, you can call it I, you can call it whatever you want. But I'm going to use P for power. Like, what power are we raising this to? That kind of algorithmically makes sense to me. What is something you could not use as a variable name? I say almost anything, 100 points. What is something you could not use? There are things you cannot use as a variable name. Good answers, KP. You can't use NA. Because NA is a reserved special character. You can't do that. You can't use like capital T because that's true. So you can't do certain things. So watch out if you're doing that. I have capital P right now. So there are some things which will cause problems. It's rare that we do that, but I think someone stumbles upon that by accident. The code doesn't work. And then you're like, what's going on? I wanted to call this T because it's time. And if you do capital T, that's a reserved character. It's probably most common. I bet a lot of people have done that by accident. Let's go right here and say 0, and guess what we've done? We have confirmed right here that this is our skeleton. Does that make sense? So the for loop is going to do this for us right now. We're just going to put here the P, and the for loop's going to do this. This is what the for loop is doing. The for loop is doing what to the value of P when we put this in here? The for loop will want the value of P for us. The for loop will want the value of P for us. I skipped one. The for loop will what the power of P. The for loop will what the power of P. I guess you could be really specific on what it does. It will replace. I like that right there, Michelle. Great job, Michelle. It'll replace. It'll input the value of P for us. Very specifically, like if we go like this would be a lot to type. It'll iterate the value of P through the vector of values we give. So it'll move the value of P through the vector of values we give. So I could go right here and say 0 through 10. And now when we go here, we should probably do something like print. I'm going to change how this works in a moment, but let's see what it does. There you go. So now it prints what we have right here. If you look at this, and we've got a very quick way to get those values, it prints the values of 2 raised to P, where P goes through the vector of 0 through 10. Now, a lot of times I like to store answers from a for loop. What am I going to have to do? And usually I call this answer or answers. What am I going to have to do on line 11? Because if I want to store to answers, what do I have to do? Paste. I think paste has more options. Print and paste can both be captured. Paste has more options on separation and syntax. Let me just see if I can answer. Hello, can you put multiple arguments in a print? You cannot. Okay, so if I had pasted this, I could have put multiple things in there. Also, paste has arguments like sep, and you can change the sep to this, and that'll create a separation right there. Also, and I told someone this last night, there's a thing called paste 0, which when you do paste 0, it doesn't put a space between your words. The default, I did paste O. Paste by default will put separation of a space, where paste 0 is like using paste, but with sep equal to nothing. So the difference between print and paste, thank you, Noah, or KP right there for a great question. The difference between print and paste is print just prints what's inside of it and doesn't, as far as I can tell, take additional arguments. And then cat just displays something to the screen but is not capturable. Probably my favorite thing to do, and you've seen me do this quite often, is to do a cat paste. The reason is because you get the options of the paste, and then whatever you get is put to the screen, but with no vector values. So it's a good way to display a message, in my opinion, is to do cat paste. So cat just displays the screen. Print is used to just print one thing. And paste, yeah, good. Another 100 points, because that got me thinking. Those are the good questions that I love when people ask, because, you know, I want to have that best knowledge that I can have. And you really, students have pushed me. First time students said, what's the difference between cat, paste, and print? I said, I got to look that up. There's so many questions in coding, and I hope my students keep pushing me to expand my knowledge and keep it fresh. Because if you don't use a function for a year, you'll forget about that function. You'll be like, what does that function do again? How does that function work? So with this right here, we need to store the value of this. So what do I need to do on here, line 11, if I'm going to store something from this? Very important for coding night. What do I need to do here on line 11 if I want to store? Now, I don't have a spot right now is the issue. I don't have a spot to store. So here's the hint. We need to initialize a spot. Great job right there, Noah. And kind of, well, kind of yes to both. So the for loop will initialize P for us. And so P will be created. The for loop will do this for us. So if we don't have P in the global environment, the for loop will make P. So it'll make the object right there and run it. So if you notice, and the 10L stands for integer format, even though it looks weird, it says L. It just means that it's an integer class of value. It's literally just 10. If you do this, here I'll show you, class of 10L will be integer, but class of 10 is numeric. So that just changes the class of the value of 10. In all instances, 10L and 10 are just seen inside of R as 10. You're saying, well, why? Integers take up less memory. Little more detail on coding than we usually get into, but it's the way in which R stores the object with double decimal precision or 16 8-bit. I don't know. Yeah, YL. Really, that's such a good question. 100 points again. If anyone Googles that, I don't know. I just know it is L. That's a good question. It's not an integer, right? I don't know. That's a good question. We need to initialize a blank vector here. Can somebody find out that? I do not know. I do not know. I'm going to show you an error, though. And this is an error I've been helping people with. When the for loop runs the first time, why will this... What? Ooh. Well, that's weird. Let me run it again. Huh. Well, it didn't do what I wanted, though. It takes uppercase P. Oh, Trace! Trace! Random appearance from Trace listening in, because you've got some computer science background, right, Trace? Holy mac, we're throwing 1,000 points. Trace, jumping in, giving some computer science knowledge. So good to see you, Trace. Talking to me on Discord a whole bunch. Trace, so good to see you in the chat. Former student Trace, right? Man, so good to see you. Thank you, Trace. Jumping in with some superior knowledge right there. Man, that's some... So integers, they take up way less memory space. So if you're really trying to make some efficient code, you probably want to store things as integers, because just like minimizing memory allocation can kind of be a goal. It's almost, with the weight of the programs we make a lot of times, it's a little bit not important. Sometimes it's more important to think about the big ideas we can do rather than saving a little bit. This is 474. Yep, Jake. Good question right there. Trace, great answer. Now, the problem with this code right now and why I don't like it is right now this code is starting with what? Yeah, awesome, Trace. That's awesome. Well, you've got tons of knowledge. Always be bringing it. Hey, Kevin, so good to see you too. Man, we're just seeing everybody today. Love it. Throw out some more points. Oh, no. It's Happy Friday. Going crazy. What's wrong with this loop right now? Someone explained to me there's a problem with this loop that we're not getting all the values. Yeah, this loop should have 11 values. Why should the loop have 11 values? It goes from 0 to 10. The loop doesn't create 11 values. It creates 10 values, as you can see up there. And the issue is right here. And some people have had this issue. Just think about what it's doing. I thought it would crash it. Apparently, it just didn't store anything. What is wrong with this loop when it runs? And the issue is right here with right here. Why we're not getting the first value. And if you've done Python, Python indexes at 0 and indexes at position in a vector, but R indexes at 1. So we're saying the first time the loop runs to store into answer position what? The first time the loop runs, it's saying solve 2 to 0. Kirsten said right there, index 0 doesn't exist, so it doesn't store anywhere. Exactly. I thought it would crash it. Like, just thinking through what would happen, I actually thought it would return an error and say, like, cannot store into this, like at position 0 or like index not existing. But it just didn't do it. So we actually need to make it index plus 1 right here. Now we run, and now you see the values are there. We have 11 values up there, so we just moved it over 1 index inside the vector. Now we have a bit of a problem, though, and our problem is going to be that these numbers don't really line up with the power. So let's change this right here, and let's say power, a blank vector here, and store this as power position, and then I plus p plus 1. And then let's store into here power. There we go. There we go. Also in R, L means literal. Jeez, Trace got all that knowledge. Love it, Trace. L means why? And what is literally a 2? Like, I know it stores it as integer format, or integer class, I should say. It stores it as the integer class, but how does that making it an explicit integer? But why literal? Like, what it means literal, but what does literal have to do with, like, yeah, Trace, man. I will say one of the students who helped me learn so much was Nick Brown. Dropping knowledge right here, I know, right? Nick Brown, shout outs to him. He has done amazing things. And he says I've taught him things. Makes me smile to hear that. Trace, keep it up, because this is what pushes my knowledge forward. Nick Brown, it was like 8 years ago, told me how R index is at 1. He actually raised his hand and said, what does R index at? And I was like, I think 1. He's like, oh yeah, I just found out online index is 1. Yeah, Python index is at 0. And I was like, oh yeah, oh cool. Cool. He was just, boom. He had been coding in Python for years, and I've still done minimum Python coding. I'd done like next to none at that point. So let's turn these two vectors into a data frame right here. I'll show you why we're doing this here in a second. We're going to turn this into a function. So let's take and let's say answer equals answer. And then these are the two what's in my data frame. Power equals power. You can see it if you're wondering. Those are the two what's in my data frame. So this says create an object data frame, make it a data frame, store into, these are my two what's in the data frame. If you look at it, looks a lot like Excel right now. Looks a lot like Excel. The two variables, great job right there, KP. My two variables, right? 100 points right there, KP. So now that we have this, and I bet there's a way to fit curves and stuff. I want to make it like graph even cooler. So we have this right here, our data frame. We could go right here and go to plot, and let's go to data frame $, answer, comma, data frame $, power. Boop, boop, boop. There we go. Really takes off. And we, a few days ago, where's my GG library? We'll put it up here at the top. We're going to make this look pretty. Library GG pub R. And question mark GG scatter. Okay, so the GG pub R stands for like GG publishing to make really nice graphics. And they also made it easier to make things like scatter plots and we have a ton of arguments right there. We're going to go down and take some of their code, and you see right here they have an X, they have a Y. We don't want a regression line. We're just using a custom color palette. Oh, and that's got a color. We didn't really use a color. Color and shape, ellipse, mean, star plot. Huh. Let's find out what happens. Let's try it. It's always good to try things. Maybe. Maybe. Okay. We want to know the power along the bottom, which will be the X. We want to know the answer. Let's just see what this looks like. Undefined. Oh. Wait, X is power, not B. We do not have these cylinder arguments, so let's remove those. Yeah, I don't know about that ellipse. That's kind of neat. Huh. Oops. There's so many options with this. Visually, it's just a neat visual to me. Like, I'm just trying to understand it theoretically. If you ever watch videos like Numberphile and stuff, your random question, what data frame are we supposed to use for assignment 3? Does it matter? 474? For 474, you are using functions. You're writing your own functions, kind of like we're doing right here. And it's going to be kind of neat what we get with this in a moment, because I'm going to probably use this plot right here. So you're not, for 474, you're not really using a data frame. You're creating a function that will show, and we might even call this visualize exponential. And we got to make it a color. So color equals, and then we of course got to do FF8200. There we go. Look at that. Okay. Kind of neat. Kind of neat. But of course we need a title to this. So let's go here and go plus GG title. And we will say the power of exponentials. And then last but not least, we're going to go right here and go, oh, no worries. Let me know if you have questions. This is a really good, the assignment is going to like hopefully have people kind of think through how to do a lot of different things, because it's a little bit choose your own adventure. Like this has been right here for me. There's a random question by Mars who says that my evaluation period is going to end. You might have downloaded like a professional version. So you might have downloaded like the developer version or the, so our studio is 100% free. Audrey, let me know. And here, I'll maybe drop the video in the chat. That's a pretty pressing question right there. Let me drop the video in the chat. Our studio should have no evaluation periods. It's 100% free. So I'm going to drop the getting started video, which shows how to download our studio. So I don't want you to lose your access to our studio right here. So here's the video right here, Audrey right now. This is my 1-minute help for downloading it. Dropping the link right there in the chat. Make sure to follow along with this video right here. You'll see, you'll go to here. You might have downloaded one of the versions that is a paid version. They have like developer versions or like enterprise versions, but it should be, our studio should be 100% free. It's free open source platform. Unless you get like the developer versions, which I've never even looked into. Thank you, Audrey, for asking 100 points. Good question right there. So what we want to do with this now is we want to turn this into a function. So we have a plot right here, right? Let's go ahead and think about how we turn this into a function. All of this right here, every single thing. Awesome, Noah, see you in class. Every single thing I have right here is now the inside of the function. Does that, who follows right here? I just wrote a big function, and everything I have right here is the inside of the function. This is my function. I'm gonna do something else. I'm gonna call this X. This just creates the plot and calls it X. So if I were to delete this, I like to like store things as smaller things. So now I just have my picture as X. It's gonna help here in a second. You'll see why. Let's take everything right inside of here and say F is for friends who do stuff together. U is for you and me. N is for anywhere at any time at all, and that's how we write a function. So now we're going to go inside the function and paste everything we just wrote. Boop. And so let's take a look. Oh, it actually looks pretty good. That's the control. Ooh, I think. Sure. I don't like what it's doing. I'm not going to reformat the bottom. I'm going to reformat this. This is Control-Shift-A. There we go. Control-Shift-A is reformat code. So I'm not going to reformat everything, just that. I don't like how it split this apart. Yeah, I just want it to be, yeah. Okay, so now that we have this as a function, I want somebody to pick what number they are raising this to. And let's say this, is exponent fun. So if someone's going to pick a number, what should be replaced down here? If somebody's going to pick a number, what should be replaced down here? So someone's going to pick a number. Tolliver's going to tell me a number, and then I'm going to be like, let me draw that for you. Not power. Close. 100 points right there. Not power. Not power. Close. Very close. So not power, but what? Not power. Close. Very close answer. Not power, but the number he gives me is 2. Now he might give me 2. So there we go. We're going to replace 2. Now let's go here and at the very end type return for the plot. And let's see if we got this. So now we should be able to go down here. We're going to delete the plot. Where's my exponent fun? There it is right there. Let's delete the plot and go right here and say 2, and we get our plot. But we can also change it now and say 3. Interesting. 8. Whoa, look at it. It really creates a lot of distance on that last one. You could say 100. Whoa. He loves big numbers. Oh, and I changed the options. Oh my gosh. I should have never done this to my R. Digits equals 7. What's default SciPen? My SciPen is ridiculous right now. SciPen 7 and rounding 7. There we go. Yeah, exactly. The for loop's doing it for us right there. So you can see right there. Look at how it exponentially takes off, especially that last one. It's really, but I bet you if we were to change the ending point over here, so we could say this is the number he enters, and well, we're gonna keep a capital number. No, so it was mentioned yesterday. Why do I capitalize those? Great. Tim mentioned that. Put a default of 2, and I think Tim made a really good point. No, wait. No, we're giving it the vector powers. Let's go end equals 10. And now we can do xfun over here and do 2, and it does an end of 10, or we could tell it to end at 100. Man, it's so cool. Just interesting how these things go. So now I have it inside of here. I can change where it's at. Oof. I wonder. We only have like a few more minutes. I would love to compare different numbers. So I'd love it to join 2 GG scatter plots. Like to overlay 2 GG plots on the same axes. Is such a thing possible? And the answer in coding is usually yes. Put 2 GG plots together in R. Combine into one graphic. Someone's saying it right here. No, they're just putting it. Combine 2 GG scatter plots. Combine 2 GG scatter plots into one. How do I superimpose? No, they're asking Excel. Combined 2 GG plots into one. Oh, man. Okay, someone's asking Sacriflow here. Okay, they've got an answer right here, it looks like. Okay, let's take a look. All right, this will be really cool. Okay, so aesthetic. Right. Dummy data should supply this. Okay. They've got a data frame, 2 variables, it looks like us. That's good. So we have to generate two data frames. They're R binding it. And so they're making a new visual. Coming back to say I fixed Audrey. RCO Pro. Great job, Audrey. That's great job. 100 points right there. And then, so they're combining this into something called visual. Then they're creating a variable called viz right here, which is the vectors, to give it a categorical. And then, okay, so then we need to create the ggplot. Okay, so yeah, I think I know what to do. Okay, so we need to create 2 data frames. So we'd have to do like an if statement. Oh man, this is a cool function. I just want to do it. I want to make it cool. I like cool functions. Okay. So we need to put in a compare. Okay. The compare number will go through the same process. The compare number has to do the same process as the bad ideas. You're supposed to do it outside of here, but we got limited time, so we're doing bad ideas. The compare will go through the same process. And so it has to do the same thing, but instead of using our number, we're using the compare number right here. And this needs to be called data frame 2 right here. So it's data frame 2. Then as they are saying right here, we need to R bind the 2 That's where I'm worried. That's where I'm worried. Row bind is R bind, so they're saying we need to row bind the 2 data frames into 1 data frame. So total DF, that's the total data frame. And they're just saying row bind the data frames are here. Yeah, that makes sense. Okay. I'm literally row binding. I'm seeing it in my head visually. I'm like, okay, bind the rows together. Got it. Yeah, that's going to make sense. And then they're creating a variable inside of that data frame. And this is like group. Call it group. And the group is going to repeat for the length. This is interesting because we have to know how long it's long. We need to repeat. Rajiv, good job today. We need to repeat whatever they entered in first, because the first data frame is the number, and then we have compare number. So repeat number, and then we have end times plus 1. That is correct. Plus 1. And then I'm scared. This is, you don't want to be doing this much coding like this without checking it. We just limited time. Okay, so that creates that. So now we have here, we're using the, we're using the total, and then color needs to be not this, it needs to be group. Oof, 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 oof. Horrible ideas were had. Group not found, group not found. Wait. No! Is it gonna be a factor? Seconds to go, Sam. I really want to make a cool plot here. It's all it's missing is my group. Error in GG scatter palette. Oh, does it need quotes? Does it, Kirsten? Oh my gosh, does it? Oh my gosh, Kirsten, 1,000 points. Kirsten to the rescue. Owen Wilson, your thoughts?
Wow.
That's not right, Owen. It's Kirsten to the rescue right there. Kirsten to the rescue. Amazing, Kirsten. Great job. To the moon. Thank you so much. It's sometimes the smallest of errors. And now we have it. We can compare the exponentials of two different groups right here. There you go. And so we made this graphic today pretty quickly. If you look at the neat little things we can do, we can see how fast 4 rises and 5 rises. Just if you compare something like 2 and 3 and look at them over a vector of like 15 values, just seeing like, man, you got to really zoom in. You can see 3 really takes off. Like the difference between exponent numbers and what you're raising really is astounding. Like 3 just really deviates from 2 being raised to certain powers a lot quicker. So it really depends on what you're raising. But yeah, Mubot talking there in the chat. Kirsten, great job. I should have noticed the format, right? It's a lot of times when we do like LM, we don't put it in quotes. Trying to think why it's like the way it uses aesthetics and ggplots. So sometimes we make just the smallest of error. And if I hope if Kirsten hadn't saved us, which so awesome job, Kirsten, right there. Great work. We could have gone and looked at the question right here and we would have saw, wait a minute, the shape or the color is supposed to be in quotes. So Kirsten, great job following along, catching the issue Brian had. And for that, we get the following plot. And you know what we're going to do? You know what we're going to do. We're going to turn it into a ggplotly because that's what we always do here. So we're going to go ggplotly around it. And we're going to make this an interactive graphic. And now look, for our work today, we get an interactive graphic showing us the different powers. We can hover over it. We can remove out any plot we want. We can zoom into the plots. Total interactivity. Really neat graphic. And that's what we've created right here. So a lot of good stuff. I know, right? You have, Kirsten, that's what I've been pushing for. The only way to fix mistakes is to make them tons of times. That is like, Kirsten, I'm making that a quote of the day because people need to hear that in the future. I only knew because I make that mistake all the time. And that is now quote 249. Kirsten, shout outs to you again right there. Thank you so much. We're going to be here teaching 474 in a second. Not literally, but great work. That I'm just glad we got it working. I wanted to make a cool little plot. And think about this. We just coded right here a pretty large function. I mean, large. Go talk to someone who codes like C++ or something. They'd be like, what'd you do? 1,000 lines? Be like, no, we did 40 lines. They'd be like, 40 lines? Like, yeah, 40 lines. Like, I'm proud of it. Awesome work, KP. Great job, Kirsten. For now, everybody. See you later. Bye.